Hello there, engineer. Welcome to Hardship Playtest. I have been playing some hours and I've gotten almost all of the achievements except this one. Let's get on with the game. I aim to show you a short play where I start by doing a hard reset, so nothing is there, and now you have the music, which I'm sorry to say I don't think it's a good idea to put this music in the recording, but I like the ambient sounds but not too loud, so let's try it like this. Yeah, full power on the gameplay. New game. So, life suit boot sequence. You're booting up. Energy level critical. Data corrupted. Resetting to factory settings. Oh yeah. So, the computer has problems. So, which way to go? Over here. Here is something to interact with. Reboot. I'm gonna see how it handles this. It works. With light so we can see. Now there is the next terminal. And there is a ghost in the machine. Trust in the guidance I offer. For my only aim is to lead you to resolution. Well, how about a status check? It needs a bypass chip. So, we will go do that on the workstation. So, start. Database fail. Data corrupted. No chip found in database. We have to do it all ourselves. Here we go. One in, one out. Like this. And there's a lot of info, and since I want to be fast, I'll let you read it if you need it later. So, control. All we need to do is click this one, but we still need to see all these messages. There we go. Control. Next. Conflict. So we need to remove traces. Like this. Go. Compliance. So drawing lines from one input to another. Like this. All of this initial stuff is mostly just teaching the user how to use the interface. So holding down Alt can remove stuff. Holding Shift can make it go vertical, like this, and Shift to go down again. So we can take this one down here and over there, and raise this one up. This looks nice. Here we go. Yes. And I will unlock next section. I will not spend any time with the wall. That's a nice little bonus, but it is not needed, so I'll skip it. Yes, boot sequence complete, partially operational, fabricate. So I'm just standing here waiting for the chip to appear. There it is. And here we go. Good. Reboot. There we go. And this should open the door. I want to, if the door is open, yes. This is the first achievement, opening the door, the bypass chip. Here is the main machine, and this has a very difficult problem. Because this one is the master. Core system control unit fail. It needs an ALU chip. Workstation is not ready. Material banks are offline. So that's the next job. Getting those material banks online. And here's the first one. So let's see what the problem is here. And get the requirements sent to workstation. Here we go. It doesn't have an inverter, no. So it knows what transistors are and how to make a nut. So 2 to 1. I will skip all the information that can be read if you need it. I'm just rushing through and making the smallest solution. And this one is straightforward. Like this. Yeah. And then there's the merger. This is a very special thing because the MOS can share a common piece. This is a very useful, let's call it compression method, like this. And we unlock. So now we have schematics, but I will not use any schematics. I will just not place that one, no. I will place this one here and this one there. And give this one a line, give this one, and over here, like this. And then up and over. Like this. Okay. There's an inverter. I'm not really sure how to make this in fewer blocks because you need to be a little cheesy, and that's not needed. Compacting, now this is needed. Yeah. So here all I can do is remove these extra bits there. Here we go. So it cannot be smaller than this, looks like, but it can be faster and it can use less blocks. How about that? So blueprint is just very, very useful, because as soon as you've made a chip, it's here. So I can put this one in. Very nice. That means we can fabricate the inverter right away. Well, maybe I need to take a typing lesson. Like that. Fabricate. There we go. There's the inverter. Here's the material bank. So reboot. Yes. So then we can go to this one. It's just powered up. This one needs an adder, and I might not be able to make an adder within my time limit, because I will not play more than half an hour. But let's go for the gates. Because it does not know what an adder is, but it knows what parts are needed. That's nice. Yeah. So, and but not. This is a pretty easy one. Two negatives and two positives, and we need power. I wonder. Well, let's make it straightforward. No, not that one. So, I like to use the mouse to move the view around, and of course click and point. Scroll wheel and right click dragging is moving. Scroll wheel click and move is view, like this. And I'm wasting time because I want to do this fast. So connecting, go. And you speed up the validation. Well, I forgot this connection. There we go. Yes. That's advanced, although it's not very not as fast as some tricky solution has made, but save this. That's an AND. Then AND. And I will start with the inverter, just like that. And then this output is not gonna be there. So when one signal, any signal is low, we will have 0 out. Only when both are high. So when this one is low, it drives this transistor. It can drive this transistor and make a low there. Like this. And then when the signal is high, then whatever this one is what the output will be. So we need a transmitter. So when this one is low, that one is off. When this one is high, that one is on. And I want this one to be on too. So that will need to get the non-inverted signal like there. And then this one goes here and over. And it has to go enough over to get these out. It has to go higher. It usually was double click to get it back to double right is not. Oh, I think that's a setting I should put on. Controls, double click to edit. Yes, that one. Yes, save. I'm used to that. No exit. Resume. Oh, angry phone. Sorry about that. So this one needs to come out. See, this one can get over here already. I can go one more step. I think, yeah, I can go all the way over here. No, that cannot. No, it can't go there, so it has to go up here. Okay, here we go. Okay. Well, for the symmetry, so did I forget anything? Does this work? It doesn't. What did I do bad? Yeah, this one cannot get into the negative. It needs this one. No, not there. That one. That one. There we go. Okay, let's try that again. All right. Well, could be smaller, could be... It could be better, but it works. That's the end. Either or. I mean, that's almost like the AND gate, except not. except not. So the OR gate it will give an output if any one of them is 1. So if this is 1, then that one is 0. So that means this one should turn on and deliver the 1. So, and then if that one is not, then we have this one. Yes? So yeah, so then B can be transmitted here. Here we are. There we go. Now why should it be over there? It could just as well be here. Well, that saves a bit. Moving the A would not help now. So here we have a fairly nice OR gate. Yes. So then the exclusive OR. This is a little bit more of a mouthful. But still, let's start with the inverter. Like this. So XOR, when one of them is 0, the output will be what the other one is. And when the output is not 0, well, when the input is not 0, then the output will be the opposite. So I need an inverter and a driver. They need to be coupled nicely together. So the driver should be when it's off. So this one can be a driver. But then I cannot put the other one there. Maybe if I put it here. Yes. There's the driver. And can I then the inverter is the inverter should be turned. Not turning the die, but turning the chip like this. There. So B needs to go here and there. Well, there's an output here. This one needs to go higher to get here, like that. I built myself into a corner because this one, no, it can't get up. Get over here and get down. All right. Very nice. The next thing is making, well, this one is easy. It can just go up there. So when this one is 0, we will transmit B. No, we don't. This one is alright. Oh, yeah, that's the usual. This one is missing. There. Now we transmit both. Yes. So when this one is 1, we want the inverter to run. So we put this one there, this one there, and this is our inverted output. Yes. No, I would like to be there, but that's not possible. Or is it? Could I not have this one here? Could I stash him? I could. Yeah, let's try that. Nope. Off. Control to select cut, Control V to paste. There. Okay. Yeah. Yeah, I think this would be an XOR gate. And it is. And it is advanced. Very nice. But that closes the half hour. So I made an XOR, but making an adder, nibble adder and byte adder, that's gonna take another half hour, I think. So let's call it quits for this mission. I hope you enjoyed. If it was okay, please let me know. I always like comments, and if you like, clicking like is very nice for me. That will let me know that this wasn't a waste of time. Have a good time.